Okay, let's talk about why you need to know how to multiply binomials. Multiplying binomials is something you learned in high school. And so let's see the importance of learning that. Mathematics to a company means profits. Why do you need to know how to multiply binomials? Well, you may run a business. And if you do, then you need to know how to multiply binomials. You see, that's what life in this great US of A is about. Enjoying our freedom, defending our freedom, making money, and living a good life. It doesn't matter about what religion you are or who you vote for or what color your skin is. It's all about making money. That's one of the directions mathematics will take you, down the road to making more money. If you're a business, making a profit is your business. And that's what businesses do, use mathematics to make more money. Let's say you live in the great state of Florida and you grow oranges. Let's look at a revenue problem an orange grower might have that involves binomials. Your business is oranges, and you are ready to bring your oranges to market. You have 600 crates of oranges loaded on your truck. At 5:30 a.m., your truck does not shift into gear. Your mechanic says it is a transmission issue. The transmission is busted. The 600 crates have to be unloaded to permit the cab to be removed and a new transmission installed. This is the first day of market delivery, and each day your shipment is delayed, the market price is decreased by $2.50. The market price for a crate of oranges is $61.50. You have 600 crates. For each day you are delayed from delivering to the market, your workers will have 41 additional crates of oranges packed and ready for the market. Your neighbor says to you that you can borrow his truck when he returns from the market in 3 days for $2,000. How many days can you delay shipment in order to maximize your profits? Should you pay the $2,000 and borrow your neighbor's truck? Let's do the math. Okay, let's first talk about what revenue is. What is revenue? Well, revenue is the price of goods times the number of goods sold. So if we let revenue equals R, then we say revenue R is equal to the price times the quantity. So for every day you are delayed from the market, your price decreases by $2.50. So let's let N be this days delayed. So N is the number of $2.50 decreases we experience in our price. Therefore, R equals 61.5 minus 2.5 times N times the quantity. Now let's figure out the quantity. Let's also say our workers prepare 41 times N more crates for delivery during our delay. Therefore, our total revenue is $61.50 minus $2.50 times N, number of days delayed, times 600 plus 41 times N. And this is your binomial multiplication. And you need to know how to do this. So, okay, let's do the multiplication. So mathematically, we have our same equation here, where N is the number of days delayed. But first, we need to multiply this equation out, because it does no good for us the way it is, like this. So we need to get this equation, R, and this binomial multiplication, to look like this. R is a function of N. That's what this N means. R is a function of N. Is equal to AN squared plus BN plus C. And then once we do that, we need to write this equation in vertex form. So we write Rn in the equation vertex form, f of x equals a times x minus h squared plus k. You may say, well, that's a lot of work and it's difficult to do. Well, it's not, because this Rn equation is the same equation as this f of x equation. It's just two equations written differently. And the reason why we write it differently is to understand what it means better. So, this is 9th and 10th grade algebra. There's nothing college about this. But first we have to complete the square, which we learned also in the 9th grade. Let's do it. Okay. So here is our first equation. Our equation we have R. And we're going to do this multiplication. So we have first term times first term times second term times first term, second term times second term. So, okay, 61.5 times 600 right here. 61.5 times 41n is right here. And then we go to second term. Minus 2.5n times 600 right here. And minus 2.5n times 41n is right here. Okay. Now, if we do the multiplication here, we get 61.5 times 600 gives us 36,900. 61.5 times 41n gives us 21.5n. Minus 2.5n times 600 gives us minus 1,500n. And 2.5n times 41n gives us minus 102.5n squared. The reason why it's n squared is because n times n, when we have two variables and we multiply them, we add their exponents. The exponents on the n is 1, so 1 plus 1 is 2. So now if we do the additions in the middle and move the 36,900 to the end, we have minus 102.5n squared plus 1021.5n plus 36,900. Now, it looks like this form. Rn a to the n squared plus b to n plus c. And where a is equal to minus 102.5, b is equal to 1021.5, and c is equal to 36,900. So now we accomplished that first part. Let's keep going. Here's our equation, and here is the standard form. Now let's convert this standard equation into vertex form by completing the square. Okay. Our standard equation. Let's move the number with no x to the left, the c. Okay. So we move the c to the left. The c is plus on the right side, but whenever you cross an equal sign, you change the sign. So it's a minus. Now factor out the a. Okay. Well, a times x squared is a times x squared is ax squared. If we factor out an a here, there's no a here, so we have to put an a in the denominator. When we multiply a times b over a, the a's cancel, and that leaves us b times x. Okay? Now, make room on the left side and put an a in front of this space. So, on the left side, we're going to make a room over here and put a space in there. And we make room inside of the right side and make a space there. The reason why we put an a there is because whatever we put inside this space, we're multiplying it by a. Let's continue. Okay. Here's our last equation. Take 1/2 of the middle term and square it. Here's the middle term. Take 1/2 of it and then square it. So 1/2 of b over a is 1/2 b over a. And then we square it. It means multiply by itself twice. So we square it, and that gives us b squared over 4a squared. Now we add this b squared over 4a to both sides. Right there. We add it to both sides. And the reason why we did that is because we really added a plus or minus this. And when we add a plus or minus to it, what that does is that allows us to make that 0. Okay. And we move that other minus to the left side. So we're going to simplify this. So this simplified, x squared plus b over a times x plus b squared over 4a squared is essentially x plus b over 2a squared. And where did we get the b over 2a? The 1/2 ba we took up here. So we say x plus b over 2a squared gives this part on the right side. And now we got to add the part on the left side. Let's do it. Let's continue. Okay. Here's our last equation. Let's simplify the left side. So we have to add that c part to the equation here. So in order to give c the same denominator as b squared over 4a, we multiply it by 4a over 4a. Well, 4a over 4a is equal to 1. Okay. So we multiply c times 4a over 4a, and that gives us minus ac, minus 4ac divided by 4a. That's a minus c. So minus c times 4a is divided by 4a. Now we can add these two equations because they have the same denominator. Okay. And so now we have b squared minus 4ac divided by 4a. Okay. Let's do it. Here's our last equation. Now we move this side over to this part over to the right side, and we change the sign. Okay. Because when we cross the equal sign, we make this a minus. Well, minus times b squared makes that a minus b squared, and minus times a minus makes 4ac plus. Okay? So we move that to the right side, and then we factor out our minus sign. Right here, we're going to factor out a minus sign, because remember, we're going to make this look like x minus h on our last equation. So we factor out this minus sign, and if we factor out a minus sign, we've got to leave a minus sign in there so it'll come back to be plus, return to be plus. So minus times a minus is a plus. Okay. So anyway, above equation is a parabola. Now let's substitute our equation into this vertex equation. Okay. We got to substitute this equation into this equation. And remember, this is A, B, and C. Okay, and we have in this equation A, B, and C. Okay, let's do it. So, okay, A is minus 102.5, B is 1021.5, and C is 36,900. And we can plug them into this equation here. And as I said before, our original equation is y equals a times n minus h squared plus k. Well, what is h? H is minus b over 2a. And what is k? K is 4ac minus b squared over 4a. Okay, so if we plug all of this in, all of these numbers in, a, b, and c, we get this equation. And if we do the multiplication, we end up with Rn is equal minus 102.5 times n minus 4.98 squared plus 39,045. That's what we end up with. So you can see that this vertex equation is the same as our quadratic equation. So when n equals 4.98 or 5 days, rounded off, that's pretty close to 5 days. So when n is equal to 4.98, this is 0. So minus 102.5 times 0 is 0. So therefore, our revenue maximized at 4.98 or 5 days, we get 39,445. That's our revenue. The market price on the first day is $61.50. So if we were able to go to the market on the first day, our revenue would have been 600 crates times $61.50 per crate is equal to $36,900. But we weren't able to go to market on the first day. But because our trucks were delayed, so our delivery was delayed to the market by 5 days. Our revenue is maximized by our equation, in our equation by our increased load and decrease in price. So therefore, R is equal to 61.5 minus 2.5N times 600 plus 41N. So let's see what our revenue is. Let's replace N with 5 for the price quantity. So the new price is 61.5 times 61.5 minus 2.5N. That's equal to 61.5 minus 2.5 times 5. And we do the multiplication and the addition, we come up with our new price of $49. So when we do get to the market 5 days later, we can only sell our oranges for $49 per crate. But our new quantity, while we were delayed, is 5 times 41 plus 600. So by the time we get to the market, we have 205 extra crates of oranges. So now our new quantity is 805 crates. So while we were delayed, our workers produced an additional 205 crates. Although our selling price was reduced to $49, our inventory increased to 805 crates. So our new revenue is 805 times $49 is equal to $39,445 5 days later. So we can thank our neighbor for the offer, but we don't need to pay $2,000 to borrow his truck. Okay, let's look at a graph of this maximization. Okay, and as you can see here, the new revenue, which is 805 times 49, is also equal to the revenue in our equation of $49 times 805. Okay, so 805 times 49 is equal to $39,445 when we do get to the market, and our equation, our vertex equation, predicted that $39,445, and it's 0.03. Well, you know, I rounded it off. Okay. So let's take a look at a graph of this maximization. And it's good to draw a graph because you can see what this equation is doing. Just calculating this is nice, but in order to see what this calculation does at different prices or different inventories, you need to draw a graph. So let's look at a graph. Okay, let's look at this graph of this our equation, and this is Rn equation, and this is the graph of this equation, and you'll see at the uppermost point of this graph, at the vertex, here is our solution. N equals 4.98, and our maximum profit is 39,445. And that occurs at the peak of this graph. That's the maximum point. So it shows that our graph has been maximized. Okay. Now I'm not going to show this side over here because this is for animation, and we're not going to be doing animation. So let's move this chart over here, and we can move our graph over here like this, and maybe move it up some. Okay, let's move this stuff down here. Let's move this down here so we can see it. And then move this chart up like that. Okay, so we can move this over here like this. Okay, so now let's see what happens to this chart as we vary certain parts of this. Okay. But first, let me explain this equation. This equation is, if you remember, we had R equals A times N minus H plus K. Okay. And K is 39,445 maximized. H is minus H is 4.98 and A is minus 102.5. And the reason why what happens with A is when A is minus, the graph opens down or it's a frown. And when A is plus, the graph opens up. It's a smile. So that's the way you can remember that. Okay, so let's look at our chart and see what happens when we vary each one of these options. We have current price, current inventory, inventory increase, and price reduction. Let's see what happens to the graph when we vary one of these, keeping the others constant. And this is a good way to look at a graph to see what it's doing, rather than just calculate the maximum price in the maximum revenue and the maximum days delayed. You can make a graph and look at the graph and see what's going on. So let's pick current price. Let's change it. So we got a current price of 61.5, 61.5, $61.50. So let's decrease that and see which way the graph moves. Okay, so let's get this back to 61.5. Okay, there you go. Now let's vary this current price. So if we vary this current price, it's moving down. And once we see our current price here is moved over to the negative, we see our days delayed has moved to the negative. Our current price is $27.50. Okay. And our maximum revenue is $16,838. And as you can see, as you decrease this current price, the days delayed and the revenue is changing. And days delayed has moved into the negative. Okay. And I got it all the way down to where I can bring it down, current price down to $1. Okay. So let's bring it all the way down to $1 and see what happens. And I mean, we could stop the current price anywhere we want to, or we can move it. Let's move it to $20. Okay. So if we got the current price is $20, our days delayed has moved to minus 3.317, and our maximum revenue has moved to 13,128. And here's our equation up here. Either one of these, but I use this one because it has both price and quantity in it. Okay, so let's see what that is. Okay, so we have let's go. So we have days delayed is minus 3.317. Okay, so that's our n. Okay, that we're solving for. Okay, so let's take that 3.317. That's minus. Okay, now we plug it into each one of these. Let's do the price first. Times minus 2.5 times 2.5, and that's minus. That gives us a plus 8.29. And we got to add that 8.29 to the current price, which is $20. Okay, plus 20. That gives us 28.29. Okay, so that's $28.29. Now is the price that we have to look for. Okay, okay. So now let's plug n into quantity. So we got 3.317, and that's minus, times 41, and that gives us minus 135.99. We add that to the current inventory, and our current inventory hasn't changed. It's still $6, 600. So that's 600 crates. So let's add that to 600, and that gives us 464.003. We can forget about that. So that means if we let our N decreased to minus 3.317, we got to sell our goods at a price of $28.29, and we got to have an inventory of 464 crates to get a $13,138 profit. Okay. So how do we do that? So that's 464. That's the total quantity times, let's call that recall. That's what our price was. And that is equal to 13,127. 13,128. Well, let's round it off. So that's right. So whenever we decrease this n to, we just plug it into this equation up here, and we'll get. And you plug it into either one, but I use this one because it's got quantity and price. Okay. So and as we vary that, we plug an n into there. Okay. So let's bring our price back up to 61.5. Okay. Now let's vary the quantity, the current inventory. Okay. So if we vary the current inventory, and I'm moving it by 50, and you see the current inventory as it moves by 50, and I got current inventory goes down to, let's say, 50. I got it 0, but it shouldn't be current 0. Let me change that to minimum 50. Okay. So the minimum, let's move it to the minimum 50. So if our current inventory is 50, that means our N moves to 11.69, and our current profit moves to, our current revenue moves to 17,083. So if we take 11.69 and plug it into these two places, we should get that. Okay. So let's do that. Okay. So we have 11.69, and it's positive, times 2.5, which is negative, times 2.5, which is negative, and that's a minus 29.22, and our current price is 61.5. So 61. Okay, let me clear entry plus 0. Let me see if I can get. Oh, I messed that up. Okay. So then let me do this over. 11.69 times 2.5, which is negative, and then I add that to the current price, which is 61.5 plus 61.5. That gives me a new current price of $32.30. Okay. So let's clear this out. Now take this 11.69, and we plug it into the inventory right here, and we say times 41, and we say plus. Essentially, it was plus. It makes it plus. But plus, what's the current inventory? 50. The current inventory is 50. So plus 50 is equal to 529. Okay. So that's 529.30, and we say times the current price, which is 32,275. And that's equal to 17,083. And that's what we got here, 17,083. And that's how you do that. And so if you draw a graph, you can look at how this changes, and you can make better decisions. Essentially, that's what you're doing, making better decisions. Okay? And this reason why 17,000 is because I divided this whole equation by 1,000, so it wouldn't be that far up the graph. I wouldn't have to zoom in to see it. So I just divided this whole equation by 1,000. Okay, that's why that says 17 point, because I divided by 1,000 this whole equation. And uh, you can do the same thing for, let's bring this back up to 600. If we do the same thing for current inventory, if our employees reduced current inventory of only 5 or 11 or 19 parts per day, if it moves over into the negative, okay? And if our price reduction moved over to smaller, our graph would move into the negative. If it moved larger, it would move in the negative. If it moved smaller, it would move, our chart would move higher. Let me see if I can bring that up here. There, it would move way up there. It'd be huge. Okay. 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 So that's how it goes. And so that's why you would draw a graph, for this. Because with drawing a graph, you can make better decisions with this. Okay. Now, when you get to calculus, this is just algebra, trigonometry, and geometry. And so we got to look at the chart to see the max up there. We got to look at this to see the max. But once we get the calculus, we just take the derivative of this and set it equals 0 and solve for n, and it'll tell us what the maximum is. Okay, that's what calculus does. And that's why we say calculus is algebra, trigonometry, and geometry with a little spice added. And once we mix it all together with that little spice, we call it calculus. Okay. And that's the way you do this. And that's why you draw a chart, so you can make better decisions. Is there anything else about this we need to know? That's about it. Okay, one more thing I want to show you about this chart is I want to show you how this chart changes from a frown to a smile. And it changes in other ways, but I've just fixed this to where it will change. Let's take the inventory increase and change it. If we go inventory increase, we go higher, the graph moves up. If we go decreasing, the inventory increase from decreasing from 41. Let's say inventory increase is the amount of inventory our workers increase per day. We're delayed, okay? And so we're moving over down to 1 crate per day. Here's where they decrease 1 crate, increase 1 crate per day. Now we keep going, and look, it's changed to positive. It's a smile now, okay? And I just wanted to show you how it changes. Okay. And let me see if I can zoom in. Okay, let's zoom in and see where it changes. I don't know if I can inventory increase. Let's see if I can run that. Ooh, there it goes. I run the animation. Okay, that's what I want to show you. As you can see, it's changing over here. See the inventory increase? It's a negative. Okay. See, that's what I want to show you. Okay, I hope you see now that businesses love math, and so should you. Mathematics is very important in your life, and most of it is high school math. If you don't ever go to college, if you just learn high school math, you'll be pretty smart. So I hope you learned something. And until next time, see you later.